When we think about teaching an AI to see, we usually think we just need more data, right? More and more pictures. But what if I told you there's a clever trick, a way to get smarter AI by being creative with the data you already have? That's exactly what we're going to dive into. It's a technique called data augmentation. And honestly, it is a total game changer.
All right, so take a look at this. Simple enough, yeah? It's a dog. You see it, I see it. But here's the crazy part. A super smart AI, one that's been trained on thousands of photos, could look at this exact image and have, well, no idea what it is. I know, it sounds nuts, but this kind of thing happens more than you'd think. And the reason why is actually super interesting.
And boom, there's your answer. It's because the AI was only ever shown pictures of dogs facing to the right. Seriously. So the AI isn't stupid, not at all. It's just laser focused on the wrong thing. It didn't learn what a dog is. It learned that a dog is this furry creature that always looks to the right. This is exactly the kind of problem data augmentation was invented to fix. Okay, so this whole situation has a name, the right-facing dog problem. It's all about what happens when AI models just learn too little. This is a classic example of a huge issue in AI called overfitting. It's basically when the model gets so obsessed with the tiny details of its training data that it completely misses the big picture. Right. So the model thinks dog literally means faces right. It hasn't seen enough variety to get the real idea. It's like if you only ever saw red apples and then someone showed you a green one, you might not think it's an apple. The model becomes super brittle. The moment it sees a dog in the wild facing left or maybe looking up, it just breaks. So the big question is, how do we fix this without having to go out and shoot a million new photos? And this is where we meet our hero, data augmentation. It's such an elegant solution, really. It's how we show our AI a much bigger, more interesting world by basically inventing parts of it ourselves. So what is it, really? Well, data augmentation is the process of creating new training data by making reasonable modifications to the data you already have. Put simply, you take one picture and you turn it into 10 or 100. You just make these small, believable tweaks to create a whole bunch of new examples, and each one gives the AI a slightly different lesson. And the basic recipe for this is incredibly simple. 1, you take the data you have. 2, you make some small, realistic changes to it. 3, you get these new augmented samples. And 4, you just toss them back into the training pile. That's it. Suddenly, your model has way more to chew on. So let's look at what those changes actually are. Okay, so let's talk about how to actually augment the data. The best way to think about it is like you have this toolkit, a whole set of transformations you can apply. Each tool messes with the image just a little bit, but in a way that creates a brand new, totally valid example for the AI to learn from. Let's open up the toolkit and see what we've got. First up, and this one is the most obvious fix for our dog problem, we can just flip it horizontally. Boom, problem solved. Now our AI has a perfect example of a left-facing dog. With just one tiny operation, you've basically doubled the variety of your data set right there. Another really common one is to slightly rotate it. I mean, think about it. When you take a picture with your phone, is it always perfectly straight? Probably not. By showing the AI's slightly tilted images, you're teaching it that things in the real world aren't always perfectly aligned. Super important for something like a self-driving car needing to recognize a stop sign from a weird angle. Then there's zooming. We can zoom in, we can zoom out. By doing this randomly, we teach the model a really crucial lesson. A dog is still a dog whether it's way off in the distance or so close its nose is pressed up against the camera. It helps the AI learn the actual features of a dog, not just what a dog looks like at one specific distance. Oh, and this one is really cool. We can even vary the color. We can mess with the brightness, the saturation, the contrast. And you might be thinking, why would you do that? Well, it's to force the AI to pay attention to what really matters, the shape, the texture, the outline of the dog, instead of getting hung up on the lighting. So it learns that a dog is a dog, whether it's in bright sun or a dim room. All right, a quick word of caution here, because this is really important. Not all modifications are equal. You can't just start flipping and rotating everything willy-nilly. There's a rule to this game. And it all comes down to this phrase, reasonable modifications. I want you to remember that. Everything you create, every new fake piece of data, has to be something that could plausibly exist in the real world. If you create something impossible, you're not helping your AI. You're actually just confusing it. Okay, this is the perfect example. On one side, what makes sense? Horizontally flipping a dog.
Totally fine. We see dogs from the left and the right. That's a reasonable change. On the other side, vertically flipping a dog? I mean, when was the last time you saw a dog just floating upside down? It doesn't happen, right? So that's an unreasonable modification. You do that and you're teaching your AI complete gibberish.
So let's bring it all home. Why does this technique matter so much? Well, there are two huge wins you get from doing this right. And trust me, this isn't just a clever hack. It's totally fundamental to building good AI today. Okay, big win number one. You get way more data for way less effort. If you're starting with a small data set, this is your best friend. It's a cheap, super effective way to beef it up. And big win number two, and this is the real kicker, you get smarter models. Period. By feeding the AI all these different versions, you stop it from getting stuck on silly details, that whole overfitting thing. It learns to generalize. The result? You get an AI that's tough, robust, and actually works out in the messy, unpredictable real world.
So that kind of leaves us with this pretty wild thought, doesn't it? We're essentially using fake data we just made up on the spot, to make our AIs smarter and more in tune with reality. It makes you wonder, what are the limits here? If we can teach an AI to recognize things it's never actually seen before, what else can we teach it to see?